Hi everybody, I just wanted to take a couple of minutes to go through exam 2 since we never had a chance to do that in class. So I'm going to go to the rubric. In PolyLearn under exam 2, we can look at the exam 2 rubric. So looking quickly at question 1a, passive cooling is just basically everything above the comfort zone. Passive heating is everything below the comfort zone, but we've seen on the psychrometric chart over and over again, and it was mentioned in class and in the reading, that below 40 degrees Fahrenheit, we really require active heating. So if you made bubbles that looked roughly like that, you would get that right. Then in the next section, you're asked to identify the 4 hottest months and the 4 coldest months. So again, just looking at the bars, I'm selecting the 4 hottest, and here November, December, and January and February. For the wind wheels, the first part was just identifying the 4 months when we would likely like to use cross ventilation, and then reading the wheels and understanding the prevailing wind direction. So again, most people got this right. When you see these yellow bars around the outside, that indicates the highest number of hours with wind coming from that direction. And then when we're seeing temperatures that are in the red, that's an indication that these are hot months. That is a warmer wind. And when we see here the blue color, that probably is indicative of evening time wind direction versus daytime wind direction. So you were to draw the wind directions. So the summer would be coming from the southwest. The winter sun is the winter wind is predominantly coming from the northwest, or we also gave credit for the northeast because in the winter months, as you can see here, we get a mixture of wind coming from the northwest and from the southeast. And then you were asked to also say the same thing in words, in diagram and words. The ventilation inlet and outlet size, as we talked about in class, is that in order to calculate this, you need to know the floor area, your average wind speed, and then your heat exhaustion. Heat exhaustion was given in the question. For the average wind speed, you would go back and look at the windroses from the previous question. Notice here, average is the triangle in the center. I realize this is very small, so I did give you the original files, or you could look at Climate Consultant. The averages all tend to hover right around 10. If you gave us the max, you might read more at the 15 or 20. We took off a half a point for that. So you needed to show your work, you needed to show the floor area, the wind speed, the heat exhaustion. You needed to show that you mapped the wind speed, you hit the 90-degree contour, that's the heat exhaustion contour, and then you came over and read a percentage. You got 1 point for that, and then you just had to times the floor area times the percentage to get a square footage of inlet and outlet opening. And in order to move on to the next question, I approximated a size of what that inlet or outlet would be. In the ventilation question, you were asked to indicate the prevailing winter wind here. We wanted to make sure that you drew the streamlines, the wind flow streamlines, as continuous lines, or at least implying continuity. We did take off a half a point or a point, depending on how many times you did this, if you drew the wind just stopping at the building. Lechner had a pretty lengthy section in your reading where he was talking about conservation of mass and the continuity of the streamlines, and went through step by step how to draw streamlines. So what we should have seen for the summer prevailing winds is a high pressure on the windward side, a low pressure on the leeward side of the building. The same situation happens at each wall, a high pressure and a low pressure, a high pressure, a low pressure, and then we would have seen these airflow lines moving through the building. Some people did put different types of fins. Some people put the window on this side with a fin in this direction. Those were all great answers. I love the fins. For passive design strategies, here I was actually asking you to really just copy the graphics that have been shown to you multiple times in lecture and are in your keynotes and are also given to you on Climate Consultant. So you were to identify the zones that indicate a particular type of overarching passive design strategy, so such as passive solar heating. Answers that were less correct on this question and the next question were where you might give a specific example. So perhaps you would have said trom wall instead of passive solar heating, and really what I'm looking for is the more broad category. So here I show 6 different options. You needed to only show 5. And one thing that we were looking for is that passive solar heating, internal gains, and solar shading are really key in this climate. As you can see, there's a density of weather data, max and min temperatures and humidities that really concentrate in this portion of the psychrometric chart. So we made it that these 3 you had to have, but then of the second 3, just selecting 2 of those were also correct. So make sure you review this question and you understand what is meant here. In the shading question, the first portion was to map the overheated period. So that should have been a pretty straight mapping from the timetable plot above onto the sun path chart. And then there was this question about if you wanted to make a modification to the overheated period. And I really feel like this is a key critical thinking aspect of this test. So this is asking you have the raw data, but based on your understanding of climate, your understanding maybe even of climate change, your understanding of the problem that's been given, that this is a passive solar heating condition where we actually want sunlight in this building in our cold months, which would be January, December, February, and November especially. It's asking you, does this overheated mask make sense given all those other considerations? So you could have said a lot of things. You could have said, since it's passive solar, you want to actually scale back this mask because you can see that we're shading in January and we're shading in February, so we want to scale it back. You could have also gone the opposite direction and said, I'm concerned about global warming. I want to make sure this building doesn't get too hot, so I'm going to scale it up. Just give us some kind of explanation of your thinking and indicate that you're able to think through looking at these graphic representations. So here I indicated with the black outline my adjusted shading mask, where I'm going to be pretty mindful of allowing enough sunlight into the building during these colder months. And then using the solar protractor, which I realize this is one of the trickiest parts of the test. So what you were asked to do was identify a VSA, a HSA, and an N-profile curve. So here in the black dashed line, that's where I have transferred my shading mask from the previous step. And what I really want to do is shade the majority of that mask. So the first thing I do is just find a VSA arc, which was right here at the 50-degree curve, and pull that out and shade everything below it, and that takes care of a lot of my overheated period. The next thing I want to do is I want to figure out where to stop my horizontal shading device. How wide should my horizontal shading device be so that I can still allow the sun in the early morning hours to get into the space to help warm the space up after a cool evening. So the end profile curves are these gray lines, and I just trace one until I get to the 60-degree angle and bring that down to where it intersects my VSA. And then I could be done, But what ends up happening is, in order to shade all of this really late afternoon sun, where I am still in the overheated period, I end up having an end profile angle of 0 degrees. And an end profile of 0 degrees means that I would need an infinitely long horizontal shading device in the west direction. So if you don't want an infinitely long, or you can't afford, or your site is not infinitely long, you might want to come up with a combined strategy where you have both horizontal shading devices, which are determined by calculating your VSA, and also I might have a vertical fin, which would be calculated through the HSA, which is related to all of these red radiating lines here. So the last thing you might want to do would be to come up with a design for a vertical fin, right? So we would use the red radiating lines that we have around the top of the solar protractor, and really I can choose any of the angles that I would like to choose, but just understand that the lower the angle that I choose, for example, if I were to choose a 40-degree line, that the vertical fin, in order to kind of meet up with my horizontal, my vertical fin would take on proportions where it sticks out from the building quite a lot. So you're trying to find a balance between a vertical fin, so here I chose 70, so a vertical fin that is shallower and might have a nicer aesthetic relationship with my horizontal shading device. So here in the next question, you were just asked to explain your thought process in selecting your HSA and VSA angles. If we start first by looking at the plan view, here I would write down my HSA angle, and remember that we are always working from the corner of the window. So the most commonly missed thing on the test was that people did a good job of identifying their HSA, they did a good job of drawing it on the plan, but then we would get vertical fins happening at every single window, which really means that this has just been over shaded. So all of this morning sunlight that was supposed to be coming into these windows is getting blocked by these shading devices. So the shading device for this window ends up actually shading the morning sun for this window. So again, that was the most commonly missed area on this entire test. So a better solution was actually to just move the vertical fin over to the westernmost side of the window so that I still allowed that morning sunshine into all of the windows, and I only blocked the late western sunshine. Incidentally, that vertical fin can go in a lot of places. I could certainly choose to extend this HSA out, and I could end up with, a carport or an arbor or a sculptural wall or something that comes way over here, and it's still going to block that late afternoon western sun. So you do have some flexibility about where you put it. Just be careful that if you put it over in this area, that it becomes a shading device for the windows behind it in the morning time. The same thing when we look at the building section. In the section, you show the VSA. I do want you to make a note. I'm showing the winter sun, and that the winter sun is actually able to enter into the space. So I would like everyone to be able to show basically summer solstice sun, and that the summer solstice sun is blocked and is not allowed to directly enter the space, but that the winter solstice sun is allowed to enter the space, which is important because, again, this was a passive solar heating design where we really want the winter months to be warmed. And then the last thing is that in the elevation, you can show the edge profile. So on my horizontal shade here, I've come up with a relationship between my vertical fin and my horizontal fin, and of course my roof overhang. And in order to determine how much my roof and my horizontal shade should extend beyond the edge of the window, I indicate the end profile angle from the corner of the window, draw that up, and where it intersects my shade, that tells me how long to make the device. Again, here I'm showing the early morning sun, and that the early morning sun is at a low enough angle that the early morning sun is allowed to bypass that horizontal shade. But once we get past, I think it was around 11 o'clock in the morning, then the sun is blocked and those windows are protected from overheating. You guys did really well on the next question, kind of talking about ways you could address this term of polyvalence, or how can you make one thing do multiple jobs for you. So operability, people talked about having the shading devices with insulation inside of them, so you could close them at night to insulate the building. The shades could actually be help with ventilation by being louvered or acting as fins. You could use it as a heat sink, or you could also plant some trees. And then for the last question, bringing it together, we actually didn't really grade this, but this is a good question to practice for in preparation for the final exam. So try to go ahead and sketch a plan and section that looks back at the psychrometric chart from earlier in the test and tries to understand ventilation, shading, passive solar heating, any other passive strategies, and really looks at how do you place thermal mass so that your passive solar heating strategy works, and also any passive cooling strategies might work. You were asked to draw the sunbeams, draw the wind flow, any other diagrammatic symbols, so maybe that would be high and low pressure, reflected light, things like that. The one thing I will say by looking at your strategies, by looking at the answers that were provided, is that many people put the thermal mass in the wrong place. So for a passive solar design, that thermal mass is acting as a battery that stores the sun's heat and then is redistributing that heat throughout the occupied interior. That means that the thermal mass needs to be inside of the thermal envelope. It needs to be inside of the glass, inside of the insulated volume. Remember, we're taking light, which is a combination of visible light and infrared light, and we're turning it into infrared light through the material. So we need to radiate that energy to the interior of the space. A lot of people were showing the thermal mass being the exterior wall on the south elevation, and that is not going to do a very good job of warming the interior space, because at night when the sun sets, most of that heat would just be radiated outside to the night sky. So putting thermal mass on a south wall might help with passive cooling. If you're in a very hot climate, then you might be absorbing heat through the day and intentionally re-radiating it out to the night sky during the night. But really, in a passive solar strategy, we want the thermal mass on the interior of the building envelope. Okay, thank you.